Magnetic Energy Solutions Incorporated, and I'm demonstrating today the magnetic energy cone. I want to go through the concept of what we're building and what we've achieved so far and what our vision is for the future. Basically, the concept comes from our own universe. You look out there at the universe, and the whole universe runs on magnetics and gravity. So our invention incorporates both those concepts. For instance, if you take the moon orbiting the earth, how does that continue to spin? Okay, and the scientists will tell you that's because it's in a situation of zero drag, and all those things we've put into this design here. However, we can alter some of those things because we have added the ability with these arms to stop an object where it's still in a greater force of gravity, or we can even use the attraction of gravity factor with this design, as I'm going to demonstrate with these two arms here and stuff. So a couple different factors. For instance, I'm using a magnetic magnetic force on one side of this arm. And if I show you the tapering of the magnets and stuff, I'm putting it in a situation where it has to take the path of least resistance because of the angling and everything. Because the arm's got it locked in, it can't go out, so it has to take the path of least resistance. On the other side of this, I'm using a magnet that's attracting to this field. So it's taking the path of greatest attraction. With one pushing, one attracting has been the way I've achieved, most of my movement. And my concept, the central force has to be constant. That is a key to the success of this. I need a constant central field. Now this particular magnet here is rare earth. It's magnetized top half one field, bottom half the other field. However, this magnet is so powerful, it can go out 5 inches from it. This is the biggest magnet that I was able to get made currently. So what I have is a double field because of the size of the magnet. Across at the top, it's only 3 inches. So it is making a double field, which is, hurting this prototype right here. I have 3 more designs to overcome this problem. This prototype is to merely demonstrate that it can achieve movement and carry a load. So that's what we're demonstrating here. We have further designs and prototypes to overcome this problem. I have to have a constant central field, and we have ways that we're going to design it to the next prototype to overcome the problem that we're seeing here with this one. But I do want to show you how much we have achieved with this, because with a small amount of funding, we're looking at a possible total clean energy solution. This design is built where it has the ability to start and stop and also adjust force, and it will turn force however much force that these magnets are pushing out or attracting to. So I'm not breaking any laws of physics here. You can do the math on it. I'm open to anybody building their own design to try to prove this don't work, because it does work if we have the constant central field, and that's what we're going to be achieving next. So I'm just updating you with their design. I'm going to run you through it here real fast. I'm going to show you my design here. We need a constant central field. The constant has to be all the way around. Top half magnetized one positive or negative, bottom half the other field. These are oriented, of course, either to attract or oppose. This side's set to oppose right now. This one's attracting. These arms are made where they raise up and down. That will give us the ability to start and stop. These arms also extend out, so I can put it at different settings. and keep it perfectly aligned, because this will slide up and down on this pole. So it has the ability to be on different settings to set different amounts of force. I'm going to put it together. These arms are made where they can only go in so far, and it prevents it from making it actually attract all the way to the magnet. And then this one, of course, is pushing away, so it don't want to go in. But we use a simple little tool here to lock them in place. And to prove that one of these designs can, achieve movement and carry a load, let me let go of it here to show you it's pushing off. And it takes right off. It's carrying a load. We need to work on having a constant field. I have 3 more designs that we're going to be incorporating into our next prototypes to do this. And my point is, this proves that it can be done and will carry load. And it'll be a direct proportion to how much these magnets are pushing away or attracting to the central magnet. So this is my demonstration for today. There'll be much more updates to come. Thank you very much for your interest in the magnetic energy comb.